Okay, hello. We're talking about the basics of matrices today. Well, matrices is plural for matrix. A couple of things. First of all, when we talk about matrices, they're always a collection of numbers, a collection of data. They can be words, they can be decimals, they can be fractions, they can be numbers, variables. Doesn't matter. There's some kind of a data inside, and we always measure them by their dimensions, rows by columns. So for instance, matrix A right here, which we are naming with this capital letter, has 2 rows and 2 columns. So this is a 2 by 2. Matrix B has 3 rows and 1 column. It is called a column matrix. Matrix C has 2 rows and 3 columns, so it is a 2 by 3 matrix. Matrix D is a row matrix because it has a 1 row with 4 columns. Moving along here, we have matrix E that is a 4 by 2, and matrix F, which is a 2 by 1. Now, sometimes when we identify different places inside of a matrix, you identify them by their location. So for instance, in matrix E, we have this x plus 1 entry. That is in row 2, column 2. Whereas the matrix element number 1 right here is in row 4, column 1. And so it's kind of like an x and y coordinate that we're looking at, but it's certainly by the row number it's in, counting from the top, 1, 2, 3, 4, and the column going vertically. All right, so topic number 2 is about scalar multiplication, and we're going to basically deal with today scalar multiplication and adding and subtracting matrices, and then ultimately multiplying matrices themselves. So for scalar multiplication, it's based off of the word scale, so it's increasing or shrinking a matrix value, and it's really just multiplication, and it kind of works exactly the way you would expect it to. So this is the scalar right here, the number 2, and then this is the matrix that we're multiplying it by. And what it means is that we're going to multiply the 2 times every element. It's a little bit like distribution, but more of it. So the matrix 2A is literally 4, 6, 2, and 10, exactly the way you'd expect it. And now if you see a negative out in front of a matrix like this, it really means negative 1 times the matrix. So negative 1b would be negative 1, negative 4, and negative 6. We're multiplying this negative 1 into the matrix, just like you do with anything else. So sometimes we combine them and we have a negative 3 times e. And so here we're multiplying this negative 3 times every element or every term. And the only place where that starts to look a little bit weird is where we've got that variable sitting, and that is where you've got to make sure you distribute it times the entire expression. Now, the size of the matrix does not change. Oops, that's a positive 12. And the dimensions are still going to be the same. So we still have a 4 by 2 matrix as a result of this.